Hello, this is Peter Schuster, and today I want to talk with you about the design process. Before we get into my talking to you about the design process, I would like you to pause this video and figure out what your design process is right now. So I'd like you to think about the last problem you needed to solve and what steps you took to solve that problem. What difficulties did you encounter with that approach? Did you think you had a flexible process? Would it work for different sorts of problems? In what ways is it flexible or not? And what part of the process did you struggle with? And then just kind of quickly sketch that out. What is the process that I go through to solve a design type problem? So please pause the video here and then come back in and I'll talk about some people's ideas of a design process. Okay, so a few examples. I'm just going to flip out a few slides here. Here is an example design process. Ask what the problem is, imagine solutions, plan out how you're going to make something, build it, learn from that, and improve it, loop around. A lot of these you'll find are loops. Identify what the problem is, define the criteria constraints, come up with solutions, brainstorm possible solutions and generate ideas. I'm not really sure why those are two separate tasks. Explore possibilities, select an approach, build a model, refine the design, and loop back around. Another one here, research, come up with a design concept, create a scale model, build a prototype, product testing and presentation. Here's one that Stanford's D School uses, empathize, define, ideate, prototype, and test. Here's another one, define, identify, brainstorm, select, prototype, test, iterate, communicate your solution. The design process game, it's kind of feeling like a game at this point, right? What do you go through? What are the tasks you go through and how do you move through them? How quickly can you do that? So there are lots of different ways at looking at a design process. And there is no really one right way to define a design process. So before I get into my suggestions for a design process, I want to talk about why we do this. We've talked about a bunch of things in this course that need to happen during the design process while you're doing a design. You need to consider lots of design considerations, things that are important. You need to understand your customer. You need to do some form of problem definition. You need to come up with solutions or ideate. You need to select great solutions from your list of all possible solutions. You do need to prototype, you do need to test. And that's just what we've talked about in this philosophy of design course. There's more as well. You're learning lots of other engineering topics and skills, and all of those apply in what we call our detailed design, sorting out exactly what that design needs to look like once you've come up with the design concept. So the reason that we have a design process is to keep track of all of this. And that's why we're talking about this at the same time as we're talking about project management, because that's also about tracking a process. So the purpose of the design process is not to constrain you and force you to do things a certain way. It's to guide you so you don't forget things along the way. And there are certain things that are better if they're done sooner, because then you don't have to do as much iterating back and changing. So that's why this is a good guideline. Again, it's not firm. You don't want to feel constrained by it, but you do want to use it as a guidance to move through. Okay, so this is my proposal. Start out with a problem definition. Go through the process of gaining empathy, understanding your user, determining what their need is, defining that problem fully by doing some background research, information gathering, and identifying criteria. So all of that in the general category of defining the problem. And then you want to come up with solutions, the ideation phase, we call it. Generate lots of solutions. By lots, I mean hundreds. Literally go out there and figure out any possible way that this problem could be solved. Then you're going to build some simple prototypes and try them out. And that trying could just be sharing them with a customer and seeing what they think about it, or just fiddling with it a little bit yourself to see what happens. These are very, very simple rudimentary prototypes for individual ideas, not a final prototype, but you want to get testing those as soon as possible. Then you need to do some sort of evaluation of your ideas and pick a solution direction. After that, you can move into a detailed design phase where you do the failure and use analysis, you do calculations. This is where most of your other engineering classes fit, is in here, and it is absolutely critical. We're not talking about it in this course because all of your other engineering classes are talking about it, And you can't get to this point until you've done the problem definition and the ideation. So failure use analysis, materials, dimensions, and manufacturability are all defined now. You're going to do some preliminary testing of alternatives, and then you're going to move into what we call the implementation phase, where you're going to build a final prototype, at least one, test that, evaluate it under various performances, and come up with a plan to go to manufacturing. It's important throughout this that you test early and often. Build very crude prototypes very early on, try them out, learn from them, keep going. Build great high quality prototypes at the end so you can confirm that your design does everything you intend it to do. And then throughout this, there's this idea of iteration. At any step in the process, you can go back and revisit earlier decisions and perhaps change as you're moving back forward again. That has a tendency to add time, as we'll talk about a little bit later, and so you need to keep that in balance as well. So just quickly, I'm going to run through these in a little bit more detail. Problem definition, you're understanding your client, developing that empathy. You're going to come up with a needs statement, gather information about what's going on right now, write some sort of problem statement, which consists of a need and then a goal for yourself. Develop specifications, your constraints or your criteria, and then verify all of that with your customer. That's what you have to do at the end of the problem definition. Make sure your customer agrees. The ideation phase, this is, for me, a fun one, frustrating at times because I sometimes have trouble getting as many ideas as I know I should, but it should be fun. It's about the creative side, making something new. So lots and lots of potential solutions, building very simple prototypes, low resolution prototypes, we call them, things with cardboard and foam core and tape and glue and yarn, whatever it takes to rough out an idea and get some feedback on it. Don't evaluate your ideas until after you have come up with lots of them. So separate the ideation creation from the evaluation stage. Analyze and do some selection of a solution, use your decision matrices there, and again, share your design direction with your customers. Share your low resolution prototypes to get feedback. The detailed design phase. There are lots of details that need to be sorted out before something can go to production. Complete analysis of everything critical about the design, the materials, the dimensions, all the calculations to support that. Specifications of purchased components, again, materials, dimensions, detailed drawings so that someone can build the parts, bills of material, manufacturing plans, economic considerations, all of these things are important to consider during the detailed design phase. It's not a focus for this class, but it is absolutely a key part of engineering a new design. The implementation phase, you're going to make a prototype and then you're going to evaluate it. So how many prototypes do you make? It depends on what you're trying to evaluate. Sometimes you're going to have one and test it in every possible way. Usually you're going to build more than one so you can do some tests to failure. You can't retest after you've tested to failure. What level of prototype should you build? It depends on where you are in the process. So if you've completed all your detailed design, you're ready to go to production, that's your final prototype, sometimes called a verification or a confirmation prototype. The evaluation is that testing phase. You're going to evaluate whether it meets all of your specifications, requirements, criteria, and so on. Does it meet the customer's needs and expectations? Get your customer involved again. And if not, then you go to this iteration phase. Again, you can do this at any point. If you're trying to ideate and you're not getting anywhere, you might go back and revisit your definition of the problem. You can do this throughout the whole process, and that leads to this question of when are you going to stop? How long do you go? And the answer is, how long do you have for the design? Design, in a way, is never really done. Every design can be improved. But we all have limited time and limited resources. So you set a time frame. Again, this is where the process comes in. Set a time frame for yourself. You work within that time frame. Iterate as much as you need in that time frame. Sometimes you have to stop iterating and say, okay, this is good enough for now. We release it. We can make a better design the next time around. Okay, so quickly to review this. I like this sort of 4-block model. Problem definition, where you're understanding, exploring, defining your problem. Ideation, where you're ideating, prototyping, modeling, and choosing a concept. Detailed design, where you're refining, specifying, and getting final approval to move forward. and then implementation where you're doing a serious prototype build and testing, and then planning to move to production. Always remembering that you can iterate throughout that, reevaluate where you are, return back to an earlier point, and repeat any step as needed within your time constraints. So that's a quick overview. Again, the design process is a guide to try to make sure you don't forget anything important and try to do the things that need to happen before others in an appropriate, timely fashion. Okay, thank you.